Think about what is written in the side of a cereal box. The side of the box tells you how many calories are in each serving. A calorie is a unit of energy. We need energy to run, jump, grow, and even think. Hi, and welcome back. In today's science episode, I will talk about describing energy.
Describing energy. Change requires energy. When something is able to change its surroundings or itself, it has energy. Energy is the ability to cause change. Without energy, nothing would ever change. Different forms of energy. Turn on an electric light and a dark room becomes bright. Turn on a portable music player and sound comes through your headphones. In both situations, a change occurs. These changes differ from each other. This is because energy has many different forms. These forms include mechanical energy, electrical energy, chemical energy, and radiant energy. An energy analogy. Is the chemical energy of food the same as the energy that comes from the sun or the energy from gasoline? Money can be used in an analogy to help you understand energy. Money exists in a variety of forms such as coins and bills. You can convert money from one form to another. Regardless of its form, money is money. The same is true for energy. Energy from the sun that warms you and energy from the food that you eat are only different forms of the same thing. Kinetic energy. Kinetic energy is energy due to motion. A car moving along a highway and a ballet dancer leaping through the air have kinetic energy. The kinetic energy from an object's motion depends on that object's mass and speed. So this is a formula for kinetic energy. We multiply the mass and speed, and actually you have to be careful because speed is in square meters, and then you divide it. If mass is measured in kilograms and speed is measured in meters per second, then kinetic energy is measured in joules. If you drop a softball from just above your knee, the kinetic energy from that ball's falling motion is about 1 joule, just before the ball reaches the floor. Let's make an example problem. A jogger with a mass of 60 kilograms is moving forward at a speed of 3.0 meters per second. What is the jogger's kinetic energy from this forward motion? So we need to solve for kinetic energy. They gave us a mass, 60 kilograms. The speed is 3 meters per second. So now I apply the formula. Now remember that in the case of velocity is to the square. So we solve this. That will give us 9.0 meters per second square. And now you apply the formula, you solve this part, and your answer will be 270 joules. Potential energy. Energy does not always involve motion. Even motionless objects can have energy. Potential energy is energy that is stored due to the interactions between objects. One example is the energy stored between an apple hanging on a tree and Earth. Energy is stored between the apple and Earth because of the gravitational force between the apple and Earth. Another example is the energy stored between objects that are connected by a compressed spring or a stretched rubber band. Elastic potential energy. If you stretch a rubber band and let it go, it sails across the room. As it flies through the air, it has kinetic energy due to its motion. Where did this kinetic energy come from? Just as there is potential energy due to gravitational forces, there is also potential energy due to elastic forces between the particles that make up a stretched rubber band. The energy of a stretched rubber band or a compressed spring is called elastic potential energy. Elastic potential energy is energy that is stored by compressing or stretching an object. Chemical potential energy. The food that you eat and the gasoline in cars also have stored energy. This stored energy is due to the chemical bonds between atoms. Chemical potential energy is energy that is due to chemical bonds. You might notice chemical potential energy when you burn a substance. When an object is burned, chemical potential energy becomes thermal energy and radiant energy. Look at the following picture that represents burning methane. When methane burns, it combines with oxygen to form carbon dioxide and water. In this chemical reaction, chemical potential energy is converted to other forms of energy. Gravitational potential energy. Consider the blue vase in the photograph. Together, the blue vase and Earth have potential energy. Gravitational potential energy is energy that is due to the gravitational forces between objects. Gravitational potential energy is often shortened to GPE. Any system that has objects that are attracted to each other through gravity has gravitational potential energy. An apple and Earth have gravitational potential energy. The solar system also has gravitational potential energy. The gravitational potential energy of a system containing just Earth and another object depends on the object's mass, Earth gravity, and the object's height. Recall that near Earth's surface, gravity is equal to 9.8 newtons per kilograms. So this is the formula for gravitational potential energy. It equals mass times gravity times height. Height and gravitational potential energy. To calculate gravitational potential energy, height is measured from the reference level. This means that gravitational potential energy varies depending on the chosen reference level. Let's make an example problem. A 5.0 kilogram ceiling fan is placed 2.5 meters above the floor. What is the gravitational potential energy of the Earth's ceiling fan system relative to the floor? So we need to find the GPE. We already have the mass, 4 kilograms. Gravity. Remember that gravity is constant, so they don't need to give us the exact amount on the problem because it will always be the same, 9.8 newtons per kilograms. That you should have memorized this. And the height is 2.5 meters. So now we just need to multiply these numbers and my answer would be 98 joules.
I hope you found this video useful. Thanks for watching and until the next one. Bye!